Now that you know a little bit about atomic variables and volatile variables in particular, let's talk about an example application of a volatile variable that is used in practice. So, as I mentioned before, volatile is relatively simple, it's relatively efficient, it's actually very efficient to ensure atomic reads and writes. And let's take a look at an example where it can be applied. And we're going to apply this to the double-checked locking pattern, which is a way of ensuring thread-safe singletons. So first we have to explain what singleton is. Hopefully everybody remembers from taking the CS 3251 course, the Intermediate Software Design Patterns course. We talked about singleton as a pattern. The singleton pattern says there is one instance of a class and it's accessible through a global access point. So there's never more than one instance. Okay, that's pretty cool. However, there's a problem. And then the problem is if you use singletons as disclosed in the Gang of Four book, the famous Gang of Four book, it's got a glaring problem. And in particular, the problem is something to do with issues related to atomicity and the evilness of shared mutable state, etc. And the antidote to the evilness of singleton when used in multi-threaded code is to apply another pattern called the double-checked locking pattern. And that actually comes from this book. And I actually disclosed this pattern for the first time. So I am credited as the person to document double-checked locking first. I was actually the first author of this book, too. So here's the issue. So remember, singleton wants to only have one instance of something. But if you use singleton out of the box from the Gang of Four book, you can end up with multiple instances of the singleton created if multiple threads come through at the same time before the singleton is initialized. Because the whole point of singleton is to basically do lazy initialization, where the first time in, you create the singleton variable. But if two threads come careening through at the same time, then you can end up with, or n threads, by generalization, you could end up with n singleton instances being created. So the question is, how do we solve this problem? And the way to do it is to use the double-check locking optimization pattern in conjunction with this concept of lazy initialization. And we're going to use volatile to make this work. So this ensures, by making this static field sinst volatile, it ensures just the right amount of synchronization. And so what happens here is we only synchronize the first time in. So we come in, whichever, let's say 5 threads all show up at the same time, calling instance on a singleton. They'll all initially find result, which is just the current value of sinst, to be 0. Then they all end up careening through into this synchronized block, the synchronized statement, and only one thread can go through at a time, because that's what synchronized means. So we synchronize on the singleton class, which is, there's always one of them, and it works fine for this purpose. So only one thread at a time gets to run in this section. And what it does is it goes ahead and it checks the second time to see if result is still null. And if result is still null, that means it's the first time in. In that case, it goes ahead and creates the singleton. But after result is set to something other than null, any other thread that comes through the synchronized block, synchronized statement, will find result not null, which means it should skip creating the singleton. So no synchronization is needed after the first instance of the singleton is initialized. So that saves your bacon from multiple initialization using the double-check locking optimization pattern. And what makes this all work are these atomic read and write operations. So here we're reading from the volatile atomically, and here we are writing to the volatile atomically. And those are atomic reads and writes. That's just giving you a sense of how this pattern works. I actually discovered this pattern. It's not like I discovered it. It had been around for a long time. I just documented it when I was working on my PhD dissertation at UC Irvine, and I was getting weird bugs in my code because I was following the singleton pattern from the Gang of Four book, but I had a 20 processor machine running, and my code was getting the weirdest errors. I was like, what is going on here? And I finally realized what was happening, and I applied the double-check locking optimization technique to the singleton pattern, and it solved the problem. Now, what's interesting is the Gang of Four book, as great as it is, was written by people who had limited experience to or with concurrent programs at the time they did that book. So they had been working primarily on single-threaded user interface style applications as opposed to concurrent programs. So when they documented the pattern, they never thought about the consequences of multi-threading. And so when someone else like me stumbled upon a scenario that used their pattern in a different way, then we had to find another solution, the double-check locking pattern, to address this. We will talk about double-check locking in more detail. It is also a very interesting pattern and generated a firestorm of controversy in the Java community for about 5 years before they finally cried uncle and added support to double-check locking in the Java virtual machine. But that's another topic for another time. Okay, so that is the overview of applying Volatile to a Java application.